Hello, and welcome back on your mathematical journey. So today we're going to talk about the distributive property. So for that, I'm going to introduce a simple example. We're going to have our three friends, Alice, Bob, and Charlie, and they're working on an art project. They're making triangles out of toothpicks, one toothpick for each side. And so we know that Alice made 2 triangles, we know that Bob made 3 triangles, and we know that Charlie made 5 triangles. And so my question is, how many toothpicks did they use in total? And so you sit down and you think about this and you say, well, what if I, add up how many triangles they made in total? And then, right, since each triangle took 3 toothpicks to make, we can take that total number of triangles and we can multiply it by 3. So, right, here we're going to take this 2 plus 3 plus 5. We're going to add them up, right? Order of operations would tell us that we should add these up first, right? 2 plus 3 plus 5 is 10. And remember, there's no symbol here, so this is going to be an implied multiplication. So we could say that this is 3 times 10, and that's a simple computation, right? That's just going to give us a total of 30 toothpicks. But now let's think for a minute and say, well, that's one way to compute it, but what if instead I wanted to just calculate how many toothpicks each person used individually, right? That should work as well. Right? If each person used a certain number of toothpicks, we can add those up, and ideally that would get us to the same result. So you say, well, wait a minute, what if I just did 3 times 2, right? 3 toothpicks a triangle, 2 triangles for Alice, plus 3 sides times 3 triangles for Bob. We want to add to that 3 sides with 5 triangles for Charlie. And now let's see what that gives us, right? 3 times 2 is going to be 6, plus 3 times 3 is going to be plus 9. And then we have a plus 3 times 5 is going to be plus 15. And sure enough, if we compute this, right, 6 plus 9 is 15, plus another 15 gives us 30. So sure enough, whether or not we first added up how many triangles they made together and then multiplied that by 3, or if we simply counted up how many toothpicks each of Alice, Bob, and Charlie used and then combined them, notice that in either case, we get back to the same result. We get back to 30 toothpicks. And what we call what's sort of going on here is we call this the distributive property. So now, right, rather than using specific numbers 2, 3, and 5, I'm going to look at here, right? I'm going to say, let's say Alice made A toothpicks, right? A just represents some number. We can just figure that out after the fact, right? Bob is going to make B triangles, and Charlie's going to make C triangles. And even though we can't necessarily combine any of these, right? They have different last names if we're thinking combining like terms. We can't really combine these any further. But what we can do is what we would call distribute the 3. So what we can do, much like in this case, we can take this 3 and we're going to multiply it by each quantity inside here. Like so. Right, 3 times A, we can just write as 3A, right? There's a plus here, so plus 3 times B will just be 3B. And then plus C is 3C. So this is what we call the distributive property, where basically if you ever have a number multiplied by something inside parentheses, you can distribute what we call the number by multiplying it by each individual term inside the parentheses. And then notice here we've removed the parentheses at this point. We have sort of carried out the operation. The only other thing I want to point out is be careful when you're using the distributive property with negative signs. So in particular, if we had a negative out front, we would want to multiply every term inside by negative 3 in that case. So if we had, for instance, negative 3 times A plus B plus C, then that would give us minus 3a minus 3b, and then lastly minus 3c here. And so you always want to be careful when you're multiplying with negatives, and that certainly applies in the distributive property case. I hope that's helpful, and I hope that helped explain the distributive property a bit, and I look forward to continuing on our mathematical journey. Have a good day.